Hello and welcome. I'm Bill Wake. We're working this week on Parser Combinators. It's an approach to creating parsers that are top-down and backtracking, but in a very expressive style. So kind of hopefully worth the trade-off. Today, we've made some progress, kind of in a spike mode of a simple parser and then several combinators that combine other parsers into a bigger parser. And I think we're to the point of dealing with recursion and pipes. We have a problem still about the return types of parsers that I haven't quite resolved in my head. I think the pipes will help with that, and we'll see what problem is left after that and what we have to do. Okay. Let's see. Yeah, our result is super nested. I don't know if we can see that. You know, we can see a little. You know, this is one and nothing and a plus and two and times and three. Um, it's not terrible. I don't know what the brackets are here. Um, but it is kind of nested. These are more of an example. It just kind of goes on and on. It's still got, I don't know if it's indexes in there or what. I don't know. It's maybe not as bad as I'm afraid, but the problem is when you do a sequence, you know, this followed by that, the type, we're returning a type of from this sequence operator. It returns the type of the first one, comma, the first value, the comma, the second value, a tuple. And then when you return another one, it's the inner tuple plus the outer tuple. And then another one, it's the inner tuple. And, you know, all these layers of tuples. And I'd rather have them flat. I don't know if I can get that directly. But the other thing is when you use this in a real application, usually you're building like parse trees or something like that. And you can build the parse tree and then just work with the parse tree and build a bigger parse tree rather than so deeply nested of just going on and on. Okay, so the recursion comes in. Let's not worry about this. Yeah, I think it's the deeply nested stuff is confusing it. When we have a grammar like this, expression goes to term plus term goes to factor times factor goes to digit or parenthesized expression, and then you're back recursive. It's indirect recursion, but it's just as it doesn't matter that it's indirect. It still creates a problem for us because how do you create how do you create E when it's building off of itself? Okay, and so one of the resources, let's see, from yesterday, this paper by Oliver Williams, he basically suggests, he calls it late binding, but it's building a parser. It kind of like build one that lets you delay it, you know, and lets you, it sort of gives you an indirect reference to it. And so you can use it in your expressions, but you use it in your expressions, and it sort of takes care of the fact that there's recursion. And let's see if we can do this thing. I don't know if I should. Well, I'm going to call it recursive instead of late bound. Recursive over some type. Okay, so the type of the parser that we're going to make, and this thing returned or is a parser. Okay, and we have to fill in some blanks. Fix. Okay, type alias. The type is going to be T, whatever the type, the inner, the result type of this parser is meant to be. Okay, and then yeah, we have to have a parse function. Okay. I don't know why it wants to put that first because I I really like this first. Okay. And the parse function, you give it the input stream in a position, and we have to um, to bind one in. Okay, so let's see. So the trick of this is we're going to have an optional parser inside. Okay, so well, inner function. Well, no, I don't know how I'll say it. Well, I've seen it called inner. The Williams paper does, and its function. It's going to be let's see. It's got to go to T optional. I guess it's going to take array of character int. It's going to produce T optional int. Okay, so I don't know if I can. Has no initializers. Okay. Yeah, I'm gonna. Okay. All right. So the deal is, well, we don't have inner. This thing. Okay. Well, let's pull this out too. Somewhere we probably have this definition, but that. And the trick is this is going to be optional. We're not going to set it until we've created our parser, and that's a little weird. Okay. If let parse function equals inner. Okay, so if it exists, we're going to use it. We'll apply it to input and position because it's a parser. And then if it's not, let's return nil 0. Optional type character T and must be unwrapped to a value of character. Oh, inner, what's called parse function. Okay. Still not happy. Oh, okay, there we go. All right. Is that going to do it? Okay. I think yeah, I think so. So here, let's pull this down. Okay. So now expression. Do we have an alternate operator yet? I can't remember. Oh, we do. This or else. Okay. So now our rule should be factor is digit or guess we can say match. Match a left parenthesis followed by an expression. Okay, so we're gonna have to make E first. Let's see if we can do this. And I'm not sure the type here. Let E equal recursive over well, it would love to be expression, but it's not expression. It's probably, I'm worried it's going to be this big, massive pair thing. T input 2. What's the type of digit? He's a match. T is, oh, great. Circular reference, yeah. Okay, I think here we're going to set this. I don't want it to be circular. Okay, can I get the type here? Not yet. What is the type of this? Hi, Rick. Nice to see you here. Let's see. Gosh, I don't know. I just want to put something. We defined expert earlier, but we're not using it yet. This is just so it could be wrong. Conflicting arguments. Match versus and then. Yeah, this is the kind of thing I'm worried about. You know, maybe I picked the wrong problem to solve first. Let's keep this. I think this is getting at the well, maybe I should focus on the message again. It's getting the problem I'm having. Okay, so somebody should be complaining here. Cannot assign value and then yeah. See, this is the kind of thing that's going on. This is it's got so many nested levels of sequences and all that stuff that it's confused. Let's see, I had a better message up here. Right. So the match here no, I didn't get this done, did I? I don't think that's going to make the message any better, but or wants compatible parsers, and the result of this one match and then it's like they can't really be compared because this one, the return type is so different. This one returns this tuple of and thens and this is why I think the pipe is maybe the way to get out of this, because then we pipe the digit to something that creates an expression, and we pipe this to something that creates an expression. And then this whole rule is an expression parser, and everybody ends up being an expression parser. So let's defer that and see if that helps. I'm going to save this off. I'm going to put this back. Okay. Cannot assign value. Okay. Yeah, we're kind of back where we started. All right. I mean, this is kind of doing something, right? It's what it does is it lets us define E as something we're going to fill in. And then in here, we can reference it. And that's really good. I mean, that's helpful. So it gives us that indirection that lets us do this kind of thing. So, I mean, I think that's a decent approach, and it's not my creation at all, right? It's definitely what Oliver Williams showed. But the type stuff is just a bear. And this stream, I mean, a stream of concatenations is going to produce, what's it going to do? Well, it's going to produce a complicated type. I would love if I could move this forward so that a stream of sequences produced an array of stuff. We could probably make everybody return arrays of expressions or arrays of something, even if it's just arrays of our return type, whatever that is, plus an int. Okay. All right. So in true spike mode, we'll just set that aside. The pipe idea, okay, it's going to be another parser, another class, and I'll just take the shape here. Okay, so a pipe, pipe of T. I may be messing up the type, so let's take a look at this paper and somewhere there's pipe. Okay, we're going to adopt the same kind of approach. So it's got a parser, and this V is a function, or it's a function returning. Oh, it's a value, I guess. So function returning value here. All right, so our ultimate target is, so pipe, let's see if we can, do we have an example? I know we put an example in later. Okay, here's pipe. Well, it's a variation of pipe. I could swear there was an example earlier. Maybe not. Okay, what pipe does though is it basically applies a function to the result of an earlier parser. So it's kind of a map in kind of functional terms. Okay, so all right. All right, so we have to initialize it with a parser. Parser of type. Okay, so this needs to be P of parser. B of anything. Okay. function identifier to name generic type PP does not control. I think that seems okay. Does not conform. Okay, sure, that we can fix. Type alias target equals T. Well, that's good. Oh, sorry. Target equals V. Yeah, that's not helping. Okay, so we got a target there. We need a function. Okay, so if, well, we need a parser too. Parser of type P, right? Okay. I don't know if we're going to need that. We're going to need something. The parser function is, it's going to be from P dot target goes to V. Sure, whatever. Okay. A parser of type P and a function of type, well, I guess we could make this a type alias. Okay, so a parser of type this and a function, map function. Okay, and parse self.parser equals parser. Self.function equals function. All right, so we've got the information. I've got to mark something escaping. Okay. Now parse input character position 2. I guess we need to be to our target, right? Target optional. Yep. Okay, because if I guess if our parser dot parse of input position is not nil, okay, so if we successfully parse, otherwise we're going to return nil. Okay, and we're going to return function applied to is that going to work? Function boolean to expected type. Boolean? Oh. Let's see the parse type. Parse result type p.target question mark int. I guess our function's going to have to take that. P.target int. So that's the result of our original parser is an optional type with an int. So we have to conform to that. That makes sense. Okay. I don't think this thing cares about the position. So maybe we only want to look at the function result. I'm going backwards, aren't I? Okay, we know it's not nil. Let's do it this way. Let parse result equal this. Okay, I think I've got everything. Oh, not quite everything. It's not conform to parser. Do you want to add stubs? See if our code. Oh yeah, this should be V. V int. He doesn't need. Do I need the int? In a way, I don't care. This paper uses a simpler model, so it doesn't have that position coming back. So you can just return the value. I'm going to say let value. I guess I can return. I don't really want it. V comma int return type pipe a PV comma target aka optional V. It's my parse. It really has to be. Well, maybe I just need to do V question mark int. Okay. Well, what I think I have is I think I can say pipe digit to int $0 dot parse of 9 position 0, and I should get back the integer 9. Oh, it's got to be array. I should get back the integer 9 because this function is going to convert the string to an int, I think. 2 times. What does that mean? Optional 9. Oh, yeah, he's optional. I can... Let's do that. 9. Okay. And, well, let's let digit as int equal that. Make sure his type is int. Oh, he's a pair. Is that the right thing? It's getting a little messy, I will say. Well, okay. I think we can get rid of some of this issue. Well, this return type is only going to get worse, okay? Because we haven't dealt with error handling at all yet, really. And it's certainly possible that a successful parse has an error. I would love to just return the type, though. I mean, okay, let's compare my pipe to his pipe. Can I do this on one screen? Not that one, this one. Okay, there's pipe. P of parser V of parser type alias target equals V. Map function, oh, R is T dot target. Okay, I guess I used P instead of T. P dot target goes to V is the same as this map function. Okay, we init a parser and a function. And then when you parse, we produce, well, this is where we diverge. He produces a simple optional target, and the position is implicit in the parse stream, the stream that he leaves, either move forward past the target or leaves it where it is if it's a failure. We return that position explicitly. Okay, if value equals parse of stream, return function of value. Yeah, so he gets by with less, and then he's got a infix operator, which we should probably add too. But I would almost like pipe not to be a parser, but he's got to be to get used. Because if he's going to show up in an expression with other parsers, he's got to be a parser. I don't know. Can I like, I would like a function that strips out that stuff, but then he's no longer a parser. So if I had, I would like something that looks like this, but it just returns V, because, or at least V optional. But if I make it return V optional, he's no longer a parser, and then I can't put him in a big expression like he did down here. Let's see. So this pipe, he wants to keep using it with other operators, and they only deal with parsers. So I think what's going to happen is my builder function is going to have to take, oh gosh, but expert.make function, what does that do? Oh, so he's saying it's producing an expression. It's a parser that produces an expression. And I'm saying, well, I produce expressions with positions. Okay. The other thing I want to do, let's see, can we, way back here, we defined exper. I'm going to make a function that give me a string, and I will give you an expression, and give me a character expression, and I'll give you an expression. How's that going to work? Now, maybe I have to take a position as well. I don't know. It's like, where's this complexity going to go that has to peel apart the stuff? Okay, but if I had a function, make digit, make number, and it takes something, a string, and it wants to produce an expression for sure. Okay, then I could certainly just call dot number of string. All right, so if I defined my digits, let's define that operator. The operator for this pipe. And I took notes, much better notes on that video. I think they do bar greater. Yeah. So we'll use that syntax. Okay. Infix operator bar greater. And I don't know the precedence. Let's say multiplication. P of parser and a value takes P of parser and function of type parser dot target to value, and it generates a pipe of PV is that gonna do it? Again, I'm gonna see what he did here. Return pipe of inner function. Function T dot target. Oh, yeah, P dot target. I don't know why it's pick here now. Okay. Let digit expert equal digit pipe to make number. I don't know, is that going to work? Oh, I do this every time. Yeah, I think the type is still to expert number 1. Okay, that's the position to start parsing from here out. It's not impossible. Okay. All right. Let's try this recursive thing again. What was the issue? Okay, the issue. Oh, I got to make another function then. The type of this one, I have no idea. All right, let's just make make op. It needs. Let's make it a string. I don't know. Okay. String. So we would want to do something like let simple expert equals, let's just do digit followed by plus followed by digit. Okay, so this is a super simple term. Okay, if that's my expression and I do simple expr, well, let SE equal, take the simple expression, pipe it to I guess make op dot parse of 3 plus 2 0 expected yeah, this is the message I wanted. Can't convert value of type string expression goes to expression to expected argument type, and then all this stuff. String comma string comma string goes to expression. String. Oh, if I did okay, this one is going to be digit goes to make number, to that, to this, to digit goes to make number. I don't know. I'm getting buried. Okay, I still expect a syntax error of some sort. The message should change, I think. Expression string, comma expression. Array of character. Oh, I wonder what that one is. Oh, that's this. The thing I keep forgetting. Okay, so is that telling me if I had a function that took expression string, comma expression? Let's define one like that. Func make op argument of type not sure what my parentheses are. I guess it's the inner. That goes to expression that we would be happy. Expected missing return. Okay. Dot op2 well, let's be explicit on this. Let expr1 equal argument dot 0 dot 0. Let operator op equal argument dot 0 dot 1. Let expr2 equal argument dot 1. Okay, and if I make an op2 of op dot first expr1 expr2 Okay. And if this is happier, okay. Optional expert number 7-1. What? Oh, let me parentheses. I was going like, how did it know 3 plus 2 is 7? That's not right. Okay. It's an optional because parsers return optionals, but it's expert op2 with a plus and a number 3 and a number 2. Okay, I think we're more than halfway home here. Okay. So now, okay, tell you what, let's take a break and we're going to come back and see if we can get this expression thing working 100%. I don't think we're going to quite let things go the way they are, but I think we've done enough experiments to see some of this, somewhat what we want. Okay, so we're going to come back and we'll try and do the matching and make this thing return its expert and all that stuff. Okay. Yeah, it may take a little playing around, but I think we can do it. Okay. So anyway, 3-minute break and I'll come back and give this a go. Welcome back. Alrighty, so let's see if we can make this thing come together. All right, so we already know digit needs to go to make number. So the result of this parser is an expression, basically. And something's going to break from that, right? I'm surprised. I would have thought the types would mismatch here. Maybe I need to build. No, maybe I need to run. He's happy. Okay. Now, this one. Okay, a parenthesized expression. Well, you know, we've left off one of the things. We don't have the operators that omit the dots. So the dot says include this. And if you leave it off here, you don't have to include that. We would love to just leave it off. So let's define a function. Oh boy. I'm going to make a function between and it's going to take an argument which is, I think it's going to be kind of like the other one, string expr, no, string, what's the type of E? I think that's the piece we're missing. E, I think maybe it is expr, and then another string. Okay, so I'm assuming match left, E, match right is the result type from this thing. And we want to get back an expression, I think. Okay. And so we're just going to return argument .0.1. Okay. Now, okay. Closure expression is between a reserved word. We'll just switch for a moment. Closure, did you mean to use it too? Do I have one too many? Sure enough. Between. Maybe this is middle. Okay. So make number returns an expression. Okay. So now my claim is this bit pipes to make middle. Oh, we're going to try this again. E. Okay, let's pull this up. Many circular reference. E equals recursive expression. Something's off. Have I got that matches? Oh, where are you? Oh, something's funny. No exact matches in call to initializer. String conform to parser. String. Okay. Let parent expression equal this stuff. Oh. I still may have a mismatch. Okay, match versus. Numeric factor, I'm just playing with names, so it's no. Let's make this. And then we can see the type of this. Match is a pipe of match expert. We don't care about match. P is a match. And this thing, okay, is parenthesized expression is this part. Okay, let's see what digit pipe to make number. Oh, okay. Pipe. It's like the types, I don't know. I don't really care about the pipe per se. Match expression. Right? I mean, I really care about the... I was hoping his type would be more like expression. I don't know. You know, sometimes... This is definitely the kind of conflict I ran into last time I tried to do this stuff. That these things just end up so nested. See, I thought piping to make number... I mean, that does seem simpler, right? It's a match to expression. No, I thought... Pipe match of expression. See, I want it to be a parser, and maybe it is. Where's my pipe? Pipe P is a parser from characters to values, expression in this case. So pipe is a parser from character to expressions. And then maybe I'm just not... Probably my between function has to be even more obscure. Okay, but if I take this and I pipe it to middle, what do I get here? Well, I think I'm still... This is where I'm confused. I think my type is... My parent type is parser from strings, characters, to expression, the last argument to the pipe. So that feels okay. Oops. Let's try that. Type of expression is ambiguous. I almost wonder... Like, this is almost like when you're in Swift UI, and they always use the sum to say, like, it's messy, but it's still something of this type. It's not going to work for me. Only implemented for declared type of properties and subscription return types of functions. Okay. Okay. I mean, this is a place where y'all can come to my rescue for sure. What am I missing? I mean, one difference. So I watched the Scott Flashen video um, from the references. This one, um, and he's working in F sharp. So there are definitely differences. But one thing that he did was his functions. He had functions that returned parsers instead of objects that were parsers. And I don't know if that's. I think that's. Part of that is a function of the fact that he's in F sharp and it's a functional language and lots of stuff's going to lean on functions more. But that makes me wonder if we did something like that, and I don't know, I'm stumbling my way through the sum thing as well, so that hopefully is obvious. Swift sum. So yeah, this is this opaque type, a reverse generic placeholder. Okay. Right. So this is this Swift UI. You say sum view, and the fact is you don't care that it's text or scroll view or whatever else stuff. Okay, so let's see what that is. Okay. Reverse generic placeholder. Okay. S1P. Right. Satisfied with the implementation. So you can think of this as looking like this. Output of P, output. Some P returns a single concrete type conforming to P. Attempting to return different types causes an error. Yes. Okay. I think this is what I care about. Opaque types composed with generic result placeholders. Right. I think that's kind of getting at P had just returned P. Two P values may have different underlying concrete types, and we don't care what the concrete type is. Um. Swift type handling is a mess. I guess that's their explanation. Okay. Hides its return value information instead of concrete type. It described in terms of the protocol. Well, that does sound kind of like what we want. Yeah, I mean, this is the thing we're seeing, these nested, deeply nested types we don't care about. Okay. I don't know. Do I want to start over in a new playground? Golly. Yeah, so let's see. Maybe take some notes. So something I'd like. Okay, let's see. PC. Okay, this is just notes. I would like. We got to deal with the super nested stuff. Okay. We certainly need the. Well, we'd like. Just thinking of those things. I maybe want a better result, a more explicit result type. Can we create versions? Can we create functions that create parsers of some type? That's the thing I'd kind of like to know the most. So the super nested stuff. The problem. Whoops. The problem is that greater returns a tuple. So series of greater returns a bunch of nested tuples. We'd like them flattened to an array. And I don't mind. I was going to say I don't mind making them all the same type, but I kind of do. I mean, there's definitely a flexibility in making them different types that's handy. Would flattening solve this issue we're seeing? So the issue is this down at the bottom. I would like to make. Oh, I still haven't piped it to the expression thing. What do we call it? Make up. No, that's not right. It already is an expression. Okay. expression should be in there. Yes. Right. So the real thing is, why is it ambiguous? Pipe match expert. Pipe a bunch of stuff that produces an expert. Gosh, they seem compatible to me. Okay. What's a small change I could make? All right, let's take this away. Now, what's your problem? Why don't you like to format right? Okay. Well, these things don't produce expressions. So, in that sense, if this parser is supposed to produce expressions, it's not going to do its thing. And I don't know if there's a good way to do this grammar to do this. All right, what did he do over here? Where is it? Here. Let's push this back over to the other window. Expression. So, open paren. Okay, left paren, right paren. He has a left paren. He has identifier followed by many expressions. He calls expert.make function on the result of those two parsers and returns an expert function call. Leaf is defined up here somewhere. Identifier pipes to expression.make leaf. Okay, let's go back here. Okay, I guess this is more like idea. Flatten to an array. idea, functions return parser of some type. They're both trying to address that same issue. The other thing, so the sequence operator P1, P2 returns a tuple well, let's say P1 result type V1 result type V2 turns a tuple of V1, V2. And alternate, it has to have the same type. As V1. I guess what I would like the array approach would say if I have P1 of type array of V1 and P2 of type V1, I would like to return you something of type V1. And similarly, if I have sequence of P1 of V1 and P2 array of V1s, I would like to get an array of V1s. And finally, P1 of V1, P2 of, this is array of, if they're both arrays, that's what I'd really like. I don't know if the Swift type system will let me make that distinction. And how do I get one in the first place, right? I don't know. Would this help? I guess the missing piece is if I had sequence of P1 of V1, P2 of V1, I would like that to be an array. That would move me forward. So if they're different, I get a tuple. If they're the same, I get an array. I don't know. Is that possible? And then alternate of array or array is array still, so that should be okay. Can we define, let's see if we can define this. I don't think that'll break anything. Will it help anything though? That's the question. So where is this? I don't get the problem here. This thing is maybe my parser. Let's go way back. Parser. I've always wondered why this would this be better as generic. Okay, let's commit this so we can back it up if we have to. Working directory. Okay. Should have done that. Get status. Okay, would this help? Let's try this. Oh, he's gonna. Oh, protocols don't allow generics. Okay, use associated types. Yeah. All right. Match is a parser, a protocol with an associated type. Um. All right. What happens if I define class and then parser one? Parser conforms to parser. Is it a duplicate name? Yes. Oh. Let's try making this. Type is array. Sure, one. this stuff should be the same. Ish. B1 of parser 1, B2 of parser 1. I guess, no rename. P. Some parser, some parser, some parser. A lot of boilerplate here, huh? Parser and parser. Now my function has to return array of P parsers. No, it's more like I think I want parser target. Surprised he's not complaining about this. Okay, and then the body should be kind of the same. Target one pause, okay. Cannot convert return type. P.target, B.target, int. Okay, so this should be array of targets. That. Okay. Now, can I mix and match my operators? Oh, come on. P1 of P. Oops. P2 of P. Returns and then array P. Wouldn't it be nice if this worked? Are you going to complain? No. Okay. Let's see if... Does that change anything down here? Okay. Let's try this. What's your type? Pipe match expert. That's just not gonna work. I don't think we got anything different out of it. Now maybe something will happen. What's T? Anybody gonna turn into an array here? Let's take this off. This should be an array, right? Match. No, they're different types. I don't know. Can I push them to be the same? I don't really care in this case. That's part of the issue. But this factor times append factor. I don't know. This grammar, when you're parsing it LL style, it's handy because you can say F leaves an expression on a stack, and then when you come in with one copy of times F, you can pop the stack, combine it with the times and the F on the right, and then leave that on the stack. But the sequence here, that's not the kind of expression you get. So we have to do some sort of post process, I guess. I don't know if I'm making any progress here. Because times is, I think, a string parser. He's a simple match. F is a pipe. So they're not the same type. Does this one match that? No. What about the simplest case? Oh, I don't think I have to run. $126. $122. $122. What is the type of this? Match, match, match. Operator is not a known binary operator. and then array match. Okay, let's try the other thing. That's a good thing. I mean, it says we did get this, and we don't have anything that matches and then array something. I laid out 4 cases, right? We didn't match the one that says and then array with a simple parser is legit. That's why this is confused, because it doesn't seem to fit either one. I would have thought it would fit this one. Operator is not a known binary operator. See, the new 122, I don't know what it's. Let me try to run this again. Why is that not clearing? There's no clean. Oh. This. Did not compile successfully. 3 matches. Where are the errors? Okay, that doesn't seem like a problem. Okay, compiling and running. What's going on? I don't know. This. Okay, is this messier? Array 1 plus 2. 2. I don't know. Okay, this is an and then parser. And I'm just trying to find out the types of this thing. An and then with an and then array. Okay, so maybe we can get our way around the combos. If we build in all these combos, 4 ways of matching arrays to arrays, I don't know. Now, could I do something to make the sum thing work? I don't know. Should I do this? And an array, they have to have the same type. These 2 parsers. So, yeah, can I define, I don't know. Other, if I have a parser 1, parser 1 is a parser. Parser 2 is a parser. And then I got some wheres. And colon parser result this. Okay. I want to say where P1 equals and then array. And then array of P2. P1 is now non-generic. Okay, if I say P of parser, okay, what if I take this off? Okay, we're going to steal all this. And see what happens. Okay, my type alias is P dot target. I don't know, this feels so hard. It just seems like this must be the wrong way to go. P1, I want it to be an array. I want it to be P, I don't know if I can do this, of a parser of array of P dot target. Is that true? Cannot specialize non-generic parser, and parser is a protocol. Man, P1 and P2 again. P1 target, which should be an array of stuff. P1 is got to be of type P1, P2 of type P2, but I want P2's target type don't know. P1's target type is, if it's an and other parser, can I say that? The target is going to be array of P, which it doesn't like. Expected closer P1 comma P2 does not conform to protocol parser. P1, well, oh wait, I do need a brace. It's worse. Closure expression. Can I just say in an array of parser? P1 and then array of parser. P2 of type parser. Protocol parser cannot conform to itself. Array other P1, P2 does not conform to protocol. That's okay, but protocol parser cannot conform itself.
Oh. I'll be right back.
X. Is that okay? Right. Tell you what, let's take a quick break. Okay, sorry. Let's see. I don't think we're heading in a direction that's going to work. The only way, okay, what if every parser had to be arrays of stuff? Would that work? But I guess that's what I'm trying to do here. I can't seem to get it to match. And this one worked because it took two parsers the same and gave them a result type with the list. But how do you get that third one in there? That's the trick. Okay. All right, let me go back to my notes from the video and just see. The other thing I saw was he used reduce. This is Scott. Basically, you pipe a list of parsers into reduce with the sequence operator, and that gives you it goes from an array of parsers to a sequence expression. But the type coming back, I don't know that it helps anything. Okay, now there is one. Sequence, he defined sequence list of parsers. Concatenate results. P1, P2. Pipe it to a list of. Okay, that may be a more productive way to go. Let's take this back out. Because I don't think I can get inside here to find out these are arrays of what type. Because I want to get to the target of the target, as it were. And that's not going. Okay. This other one, I can put it at the bottom. So let's try. This form would be taking a list of parsers and producing a list of results. I guess that's handy, but it changes the style. So instead of, so I guess you'd be doing something like P1, P2, P3, pipe 2, this sequencing thing, which doesn't match any of these sequences, so it's probably a bad name. Let's just call it seek for now. Okay, so if you pipe those to seek, this is in the functional language, right? That's the same as calling seek of this. Well, I guess it would still be an array. But you could define that function to like kind of be like our sequential operator is now, right? It would peel off each of those, append the result, and assuming they all passed, it would return it. And really, I mean, you don't need the array notation either. You could just be sequence of that stuff. Now, I guess in Swift, we could do something like we could create an array operator, right? That does it. P3.sequence. Well, that name's not taken there, so dot sequence would be calling this function that does all that stuff. Okay, so let's try that. And again, we're still in very spike mode on this. We're trying to figure out something that'll work for us. If the greater, all that stuff, I mean, that's nice, but if I can't use it, I can't use it. The problem with sequence is it's got to be a list of parsers, a list of something. I don't think I can have a list of parsers producing different things. That's the problem. How's that going to help us? Ugh. Okay, let's see. If we have this function, seek, and you give it an array of parsers, can we do that? Produces a parser. Is that going to work? Can only be used because it has self. All the types in an array have to be the same. That message doesn't help me much in that sense. It has self-associated type requirements. I guess if I put it in a class and do all the rest, I guess that's kind of why we had to do that. Okay, so if we did class seek and well, I guess we need all that. We have to have a parser. Okay, seek of a bunch of compatible parsers is a parser, and right, protocol stubs. And maybe I'm back to this. Seems not to perform. Well, we know we need a parse function. Okay, so the idea would be I guess we need an array of parsers. Of type P, and net parsers of type P. Okay, and then if we did I guess we have to do a reduce. Initial result is an empty list. Next partial result parser throws result. If I could ever remember this thing long enough to use it. Now we need to take a result. So result dot append This has to be a pair. Zero. Position. Start with empty position. And I guess this is array comma position, old position, and parser in array.append. Well, we're going to do some parsing. Let parse result equal parser dot parse input old position array.append parse result dot zero, the target. And then we'll return I don't know, array and parse result dot one. Type of array sequence p dot target. Golly. Ugh. Start is array of target equals empty. Nil requires a contextual type. What contextual type is that? Oh. that is a little weird. I don't know. Let's assume none of them are nil for now. What's going to happen from there? Parse exact matches append call. Let's see an example here. Reduce array. These don't look like what I want. No, I'm not. Array.append. What's the type of array? Sequence of p.target. Well, it's an array of stuff. Isn't... Okay, let's find array in Swift. Create a new collection by kicking out the elements of a sequence and a collection. Maybe that's more like what we want. Not to provide, okay, array of array of p.target. Start is array of targets. Let's make sure. An array of seek of p.target. Okay, we are seek, so that's okay. So an array of targets. I guess plus is not doing what I thought. Arrays of type seek of p.target. Why is that array of target? p.target is the array. Seek p.target, array of p.target, and p.target. Binary operator. Okay. To add a single element, use the append. Maybe I messed up before. Can I do append? Let array result equal array dot append. Okay. Missing return. Okay. Return this. The result of parsers dot reduce. Okay, so the key thing is the position is whatever position we accumulated so far, we keep adding to it. Okay, so I have seek. Let's try digit seek of that. Okay, let Q equal that, and the type of Q should be some sort of parser. Sequence of match. Okay. Q.parse of array. Hey, it can be taught. Okay, 27 at 0. Okay. 2, 7, and position 2. Okay. That's helpful, maybe? A sequence of parsers. The restriction is they all have to have the same type. Okay. All right. So I think this is a good place to stop. We made a little progress. I mean, I think today we got the pipe and the recursive thing maybe kind of working, but we can't tell because of this type mismatch that we got going on. I think maybe the sum type, SOME, maybe where we have to try tomorrow. Because I feel like these complicated expressions, like and of this, of and of that, a pipe of the whole thing returning expression. Well, it returns expression. It should be compatible with anything else returning expression. So maybe some can save us from that problem. I don't know. We'll just have to see. But yeah, we're getting some special situations where we can handle it like that, and we'll go from there. All right. Anyway, tomorrow is Wednesday. Next time is 10 a.m. to 12:30 p.m. Eastern or 3 to 5:30 p.m. UTC. And thanks for joining. And if you have any suggestions, I'm always open to them because I clearly don't know what I'm doing all that much on this stuff. So here we go. All right, take care. Bye-bye.